am Ji-hyun Lee, Professor of Food Science and Nutrition here at Busan National University. Welcome everyone. We are gathered for the talk concert for BrainLink X Lab Day in Multidisciplinary Approach in Sensory Science, from chemical senses to food behavior. First of all, I would like to thank the Korean Federation of Science and Technology Societies for sponsoring the BrainLink X Lab Day and Talk Concert. Dr. Han-seok Seo from University of Arkansas and I are very honored to be co-organizers. I'm the chair of Sensory and Consumer Science Division at Korean Society of Food Science and Technology. We were just subdivision of over 800 scientific societies until last month. But thanks to every sensory scientist coming together during application process for the BrainLink X Lab Day, now we are one of the 19 selected X Lab Day programs. Thanks to COAST BrainLink X Lab Day, I'm honored to have 9 distinguished researchers in sensory science field from Canada, Denmark, Japan, Netherlands, New Zealand, and the United States. When we invited you, it was very vague, but you committed to our invitation in such a short notice, and you kept your words. Your passion for sensory and consumer science field was very inspiring, and we hope we can collaborate and foster friendship going forward. Now, let's take a few minutes to watch BrainLink X Lab Day introduction video.
Amidst the world's rapidly accelerating changes and competition, what kind of future are you preparing for? We are chartering a path to the future through science and technology exchanges, bolstered by international cooperation. In this era, where scientific and technological competitiveness is directly linked to a nation's diplomacy and security, the power to overcome such challenges lies in international cooperation that fosters synergy through collective efforts, and from talents who will shape the forthcoming era. The scholars of the world are gathering in Korea. A platform that facilitates exchanges between Korean and international scholars, as well as between seasoned and emerging researchers, is taking shape. BrainLink X Lab Day, organized by the Korean Federation of Science and Technology Societies, aims to be a global hub of talent. By consistently enhancing and expanding the global talent network, we're laying the groundwork for a brighter future. By inviting global scholars, X Lab Day provides an opportunity for young Korean researchers to glean insights from the vast knowledge and experience of both Korean and international scholars, as well as to engage in collaborative research. BrainLink X Lab Day establishes a global science and technology network among overseas scholars and Korean researchers. And in 2022 and 2023, a total of 24 BrainLink X Lab Day sessions were held in each technical field, with 787 participants, including 161 from overseas and 626 from Korea, building a global human network. Also, talk concerts, one-day public seminars, were held in collaboration with the 2 nights and 3 days of BrainLink X Lab Day to enrich their experience. In 2024, BrainLink X Lab Day will be joined by globally renowned scholars, including Professor Luke Pyeong-se Lee of Harvard Medical School in the field of nanobiophotomics, Professor Ji-won Kim of MIT in the field of nanotechnologies, Professor Andrew Goodwin of University of Oxford in the field of materials chemistry, Emeritus Professor Teruo Okano of Tokyo Women's Medical University in the field of regenerative medicine, Jeffrey Newmark of NASA Goddard Space Flight Center Research Astrophysics in the field of solar physics, and Professor Dan I. Anderson of Uppsala University in the field of antibiotics resistance. The discussions will span 12 national strategic technology fields, pivotal to Korea's advancement, including the three game changers: quantum mechanics, nuclear technology, and AI. The event will see the participation of 40 Korean and international scientists and engineers. With two organizers leading each technical segment, the gathering will foster in-depth academic exchanges, encompassing the sharing of recent trends and information in core technology fields, in-depth discussions on research findings, and the sharing of ideas. And talk concerts will be held in collaboration with all BrainLink XLab Day sessions. The focus of XLab Day is connectivity and sustainability. Following the event, communities and clubs will be established based on each XLab Day session to ensure ongoing dialogue among attendees and promote collaborative research. To ensure that today's dialogue becomes the seed for tomorrow's magnificent achievements in scientific and technological development, COAST supports the reinforcement and expansion of the networks established through XLab Day. COAST, the organizer of XLab Day, stands as a beacon for Korea's science and technology society. Established in 1966, its mission has been to safeguard and amplify the rights and interests of scientists and engineers. Our endeavors extend to enhancing the public's grasp of science and technology and furthering its development through comprehensive policy research, planning, surveys, and consultations. As Korea's largest science and technology network with over 600 affiliated organizations, we are committed to promoting domestic and international cooperation and exchange. In the transformative era of the Fourth Industrial Revolution, where science and technology spearhead groundbreaking challenges, COAST remains dedicated to its role as a facilitator of scientific and technological innovations.
안녕하십니까. 한국과학기술단체 총연합회 회장 이태식입니다. 과총은 사회참여 확대와 권익신장을 도모하기 위해서 1966년 설립한 공익법인으로서 과학기술단체 육성 지원과 다양한 정책 연구, 기획, 조사, 자문을 통해 과학기술 발전에 기여하고 있습니다. 저는 2023년 과총회장으로 취임하여 새로운 도약을 위한 비전 프라이드 코스를 선언하였으며 이를 실현하기 위한 운영 목표와 추진 전략을 중심으로 빛나는 100년을 향해 모든 역량을 집중해 나가고 있습니다. 더 나아가 우리나라가 미래 핵심 기술 분야를 선도하는 기술 주권 국가로 자리매김하도록 국가적인 원팀 플레이를 이루는 데 있어 강력한 조력자가 되겠습니다. 대단히 감사합니다.
In this era of technological dominance, we will navigate through the fierce competition by fostering global cooperation in the fields of science and technology. BrainLink XLab Day aims to broaden both domestic and international talent networks and become a global hub of talent. By making XLab Day into an event that scientists and engineers worldwide eagerly join, we intend to elevate Korea's global standing and bolster national competitiveness. Global Talent Hub, BrainLink XLab Day.
Now, I would like to introduce to you overseas organizer, Dr. Han-seok Seo. Dr. Seo is professor of food science at University of Arkansas, Fayetteville. He is the founder and director of Global Center for K-Food. He will briefly explain about the overall program.
Thank you. Thank you, Dr. Lee. Okay, good afternoon, everyone. Good afternoon. My name is Han Seok-seo from the University of Arkansas Systems Division of Agriculture. It's my great honor and pleasure to co-organize the BrainLink X-Lab Day event and its talk concert with Dr. Ji-hyun Lee in Busan. She's the chair of the Korean Sensory Science Network. So we are, and we have 9 renowned scholars in sensory and consumer sciences around the world. So 3 scholars from Asian and Oceanic countries, such as Dr. Tachiko Hwa and Dr. Nobuki Sakai from Japan, and Dr. Mei Peng from New Zealand, and 3 also renowned scholars from European countries, Dr. Sarah Jaeger and Dr. Janice Wang from Denmark, and Dr. Paul Smith from the Netherlands. And 3 scholars from the US and Canada, so Dr. Soo-hyun Lee and Dr. Han Seok-seo myself from the US, and Dr. John Kostroff from Canada. Let me provide an overview of today's programs. So we have 8 fascinating and insightful talks lined up, focusing on sensory and consumer sciences. So we can classify into 2 segments. The first 4 speakers deliver oral presentation on concept and application of sensory and consumer sciences. And then the next 4 speakers will provide overview, oral presentation about the toolboxes and advanced technologies that can be utilized in sensory and consumer sciences, particular emphasis on artificial intelligence and data sciences and neuroscience. So following these talks, we'll have Q&A and panel discussion sessions. So if we have any questions during the presentations, please hold for these sessions. Okay, so we can have Q&A sessions and all questions and answers at the end. So this talk concert is designed to be casual and open to general public. So I don't want to make any kind of serious in this talk concert. So I suggest this one. So if Dr. Lee say the BrainLink X-Lab Day, and I'll follow with talk, and then I invite all of you to say loudly concert with some X gestures in any way you prefer. Okay, so you can do it this way or this. So you can do in any way you prefer. Okay. Are you ready, Dr. Lee? Yes.
2024 BrainLink X-Lab Day.
Talk.
Concert.
Okay, thank you. All right, so thank you so much for your attention and also kind support. Okay, so let's begin. So it is my great honor and pleasure to invite to address Dr. Sarah Jaeger. She's a professor at the Aarhus University in Denmark. So yes, please join me in welcoming Dr. Sarah Jaeger.
Hi everyone, and thanks for joining us today and coming. 10 minutes to talk about the sensory and consumer science, past, present, and future. It's a tough task, and I hope you have questions, and also that you possibly disagree with some of the things that I've chosen to put in the presentation today. I'm going to start, and I've put in a number of papers also for if some of you are interested in digging more into some of this. Past, present, and future. This paper represents a little bit of the past and the present. It's a paper that I wrote with Dr. Herb Meiselman and some other industry colleagues a couple of years ago, and it gives an introduction and an overview of the field of sensory and consumer science, which is coming up to having been in existence as a field of science for around 100 years. And if you look at where the field comes from and what it's doing, we, in this paper, essentially traced the history back and sort of divided it into 3 periods, where the first was around various focused on sensory evaluation, as you can see up there. Then there's a sort of a period, which was around the time that I entered into the field, in period 2, where there was an expansion of the types of topics that interested scholars in sensory and consumer science. Period 3, from the 2000s onwards, is a further expansion of the field, a further emergence or broadening of the types of things that interest us and the types of methodologies that you can look at. So here's another way of showing this very briefly, and we've put in, and this is just a couple of the sort of key points from that particular paper around what are some of the fields and topics that have dominated the area of sensory and consumer science. And when we've divided them like this, it's not to say that these topics were only of interest then and are not of interest now. It is to indicate that that is the type of period where some of this work began. Some of it is no longer interesting, some of it is coming back and receiving more interest again. So it's just trying to scope out what has happened in the field. Today, though, I wouldn't say that period 4 has begun, because we don't really have sort of created a definition of that, but clearly within the notion of sort of talking about periods, period 4 would be the future, some of these emerging and new topics. So I'm going to do this in a not very systematic way. What I'm going to do is throw at you some ideas of some things that I think we as a field need to think of. And the first thing actually is trying to define what is the field of sensory and consumer science, because surprisingly there is no definition of what sensory and consumer science is. There are definitions of what sensory science is, but there are no yet any definitions of what sensory and consumer science is. So this is a definition, I should say a draft definition that I'm working on with some colleagues. Again, Herb Meiselman and another of my colleagues from Denmark, David Gjerkelone. It's based on some work that we did, began at Pangborn, was it last year? And it's trying to condense very shortly here, so I can read it aloud to you, with sensory and consumer science being an interdisciplinary field that encompasses sensory-only research, but also consumer-centric studies, focusing both on responses to specific products and consumer behavior. So that sort of gives quite a breadth. As a field, we're primarily food-focused, and that would be the dominance perhaps in this forum, but we have to acknowledge the presence of non-food interest. We use both quant and qual methods, and that sensory and consumer professionals engage in both basic academic research, but also applied consumer research in an increasingly global context. Now, in fact, this is quite an unsatisfactory definition, because it doesn't really say specifically what we do or specifically what backgrounds people come from when they do this. But we've gone through many iterations, and that was as good as we could get, and with also some support. So if you have any comments on this, I have my email address later on, or you can come and talk to me. I'm very keen to hear this. We're in a process of preparing a paper that sort of tries to encompass as many views around what might this field be. So anyway, I think that's an important step for us to think about. So now here comes this smattering of different things that we might want to take to think about. The first paper that I've pulled here, and you can see it, it's upside down. It's actually a paper from 2009. Eb Kuster, who sadly passed away a number of years ago, who was one of the people that came from psychology and was part of founding our field. And I've highlighted here in yellow. The point is that what Eb Kuster is telling us is that many of the methods that we're using today and that we're drawing on are not necessarily resting on some strong and good assumptions around what we know of human behavior and how people work, so that we are too focused on conscious and explicit methods, and that there is an important need to rethink some of the methods in general that we use in sensory and consumer science, and also that, as the last point highlighted in yellow there, with situational, observational, memory, and expectation research. So the point I'm trying to make here is, if you haven't read this paper, by all means do it. It's a very illuminating paper. Even though it's old, it has many important messages for us continuing. Next, completely unrelated, is as a point around descriptive sensory panels. Now, for many years, there's actually been a decline in interest in descriptive sensory panels, with a greater focus on consumer-derived product characterization, for example, kata methods, yay. My prediction is that trained sensory panels are going to experience a bit of a resurgence, and I think it has to do with some of the challenges we're facing around sustainability and novel foods coming through sustainability, because some of these are needing a lot of approvals, and we may not be able to test with consumers upfront when some of this through novel technology and processes, so there might be a need for us still to have access to trained sensory panels. The next point here, again, all of these points are completely unrelated, so it's like a bag and I'm just throwing ideas at you, is that my prediction is that we need to pay more attention to data quality. So now here I'm thinking specifically of consumer research, and I'm thinking specifically also on online surveys and experiments where we collect data through different platforms, that we pay attention to the quality of that data. Data, clean it, think about where we got that data from. There's not been a lot of focus on this yet. I encourage you to think about that. And there's a reference to a paper that at least starts us thinking about why we should be doing this. Then artificial intelligence, you heard that in the introduction, and we're going to be hearing something more about it from one of the other speakers. I think I'm more flagging it as a general thing, and it's not a necessarily prediction about how it's going to go. Again, if you're interested in this and haven't done much reading, there's a nice paper here. I think two things that I think is worth flagging, actually three things, I should have put one more thing on. I think in terms of education, training people in computational thinking skills, I think it's going to be really important. In education, I think there's going to be a huge shift towards computational sensory science, and I think the last thing is about generative AI and the role it's going to play in paper writing and our research. So, the green transition is going to be really, really important. Again, here are a couple of papers that you can think about. The last one down there around some of all of the technologies that's going to happen, and the key thing is we need consumer insights for all of them. So if you're interested in that, there's a lot you can do. So I'm going to switch over to a couple of my own more sort of thoughts around what I think we need as a field, which can be summarized in this core sentence down there: more diversity in topics and in people. And there are two slides here. One around more topic diversity, and a suggestion that we think about the types of topics and the things that we interest us in through this first line up there, that consumer behavior is a set of processes by which consumers come to learn, desire, acquire, and use, dispose of goods, services, and activities available in the marketplace. That type of thinking that's much broader, that can be applied to the things that interest us. And you can find that paper. And here, the next one, again, a citation to a paper, and it's really about more diversity in the people that we study. And if you don't know this acronym WEIRD, then it's here, and it stands for Western Education, Educated, Industrialized, Rich, and Democratic, and that we need to go beyond that group of people if we're really serious about understanding people and making some changes. A final paper, if you are interested in this, that we just published in Food Quality and Preference, which is a very nice overview of where food science is, where sensory and consumer science is, compared to, for example, fields like psychology. It's an illuminative paper around what's actually going on and the types of biases that's around in publishing, for example. And with that, here's my email, and I look forward to questions and other ideas for what we should do in the future.
Thank you so much, Dr. Sarah Jacob, for your wonderful presentations. So, from the floor, there will be some questions, but please hold for the panel discussion session, okay? So I would like to invite the second speaker. Dr. Soo-Yeon Lee. She is a professor and director in the School of Food Science at Washington State University in the United States. I would like to invite Dr. Lee in the podium, and please join me in welcoming Dr. Lee.
Good afternoon. Thank you very much for the invitation to present this very prestigious and new conference, BrainLink X Lab. I thought, oh, the name in itself is very novel. I'm going to actually switch gear to a very specific area of research, especially that is very keen to sensory science, sodium reduction. So I'm a food scientist, food engineer trained, and so it's mainly focused on evaluating food systems, especially in terms of reducing sodium. Sodium overconsumption is a global issue, including Korea, but also the US. In 2010, which is about 14 years ago, as you can see in this global map, the mean global intake was around 4,000 milligram, right here, and the World Health Organization recommendation is around 2,000 milligram. In the US, the daily upper intake is around 2,300 milligram, which is about a teaspoon of salt. In this map, you can see there aren't many countries that have that blue area. Most are exceeding the amount. In the US, 90% of the population exceeds the upper intake. And my presentation is going to revolve around the US sodium consumption. I put that in the context because different countries actually have different foods. As you can see in Korea, there's a lot of soup and rice and other banchan, the side dishes, whereas in the US, it's the main dish, right? And so in the US, the sodium is really mostly in the packaged and processed food. Only about 30% of food consumed in restaurants and home is pertaining to sodium consumption, whereas the rest, 70%, actually nowadays they say about up to 77% of sodium is consumed through processed and packaged foods. Within that category, the top 3 foods are breads, grains, and cereals. And that's kind of surprising because you think, oh, bread's not salty, but it is, containing a lot of salt, and it's a staple food like rice in Korea. So not many Americans consume just one slice of bread, but multiple slices. So it is one of the top 3 food categories for overconsumption of sodium. And then the meat category, the protein category, so red meat and poultry, mainly the cured meats like ham and sausages and bacon, as you can imagine. And then the dairy foods and, of course, the cheese contains a lot of salt. In 2010, recognizing that there is a need for reducing sodium, Institute of Medicine published a report that we need to actually have active research on sodium reduction, and they had 3 different pillars to indicate where are the research needs. The first is to understand how salty taste preferences develop throughout the lifespan. So this is very near and dear to sensory scientists' heart, and I think a lot of research in Monell chemical senses actually focused on this particular area. and then developing innovative methods to reduce sodium in foods while maintaining palatability, physical properties, and safety. And that's the area that I will be focusing on, as my background is a food science, food engineer background, and developing new novel food was kind of the area that I was focusing on. And then the third area research need that IOM identified is to enhance current understanding of factors that impact consumer awareness and behavior relative to sodium reduction. In the United States, a lot of attention is being put on for fat reduction and sugar reduction because obesity is a problem, obviously, in the US and globally. But sodium reduction hasn't been a target. It's been a target recently, starting in 2010 with this report. In my research group, we have published a scoping review. It's quite comprehensive review in the Comprehensive Reviews in Food Science and Food Safety. And I would like to, for this talk show concert, focus on this review. It's like I'm giving you a literature review before I give you the actual research data in my presentation on Thursday. That's 30 minutes. So this is the literature review that I will be focusing on. It's a summary and within 10 minutes. If you want the details, the paper is open access. In the review, we talk about some strategies that we find that are mainstream in the literature for sodium reduction, such as stealth reduction, stepwise stealth reduction, where you're actually just reducing sodium without any mitigation strategy, and then salt replacement, mainly potassium chloride, and then flavor enhancement, mainly using umami type of flavor, and then some physical modifications, so such as having different distribution within solid matrix, or actually even changing the physical properties of the salt itself. In our literature review, we had some eligibility criteria, such as we only took 4 different types of literature: the research articles, primary studies, and then the literature reviews, book chapters, and patents. And we focused on papers that were published after 1970, so it's about 50 years worth of literature, and only papers written in English, because we could only read in English. And then subject topic needed to contain sodium reduction as well as sensory science. We used the PRISMA method to actually come up with the pool of literature that we were going to focus on in the literature review. And initially, when we investigated using different bases, we started with the 1,010 papers and patents and other literature. And then when we removed the duplicates and also really focused on the subject content, we came down to 277 papers. And so that's the number of paper that is encompassed in this literature review. When we look at the findings, the food category that is widely examined in the literature, it's actually corresponding with the 3 food categories that are major food categories for sodium overconsumption in the US. So the cured meat category is number 1, and then the breads, rolls, and tortillas number 2, and then the cheese category. So it really does mirror the consumption in the literature, what's investigated. And then the major categories of sodium reduction strategies, we see that salt replacers, namely the potassium chloride, is the major strategy that is investigated in the literature. And then salt removal, which means you're just removing the salt and doing nothing else to it. So mainly like the stealth reduction. That's second strategy. I don't know if you can actually call it a strategy or just removing the salt, but that's one of the main categories that you can find in the literature. And then flavor modification, mainly using the umami ingredients like monosodium glutamate, MSG, and related chemical compounds. Physical modification is rising, but still is in the minor category if you look for it in the literature. This is an interesting slide where we're looking at the years and what type of strategies are being published in the literature. Oh, 2 minutes, okay, I'll go fast. So you can see there's a big boom in 2010 where the publications were really big in sodium reduction. And salt removal, denoted by blue circle, they're the ones that are still being widely published along with salt replacers. We do see that flavor modification is becoming popular in terms of being investigated and being published. Other literature modalities, highlights I listed here. In terms of literature review, they do follow the primary studies, the research articles, in the ranks of protein first, grains, and milk and dairy. That's what you find in literature reviews. Patents, they do follow the strategies. So salt replacer strategies are number one in patent and flavor modification. And then you find bitter maskers and blockers along with the flavor modification and salt replacers. In terms of book chapters, there's only about 10 within that 277 publications that we investigated, and the main focus is on the protein foods, and each and every chapter actually contained the salt replacers. So salt replacer remains to be a very popular strategy. Notable findings, again, most investigated category, meat and poultry. Salt replacers, number one strategy that is investigated, and up-and-coming strategy is flavor modification, mainly in the umami taste because of the synergistic taste relationship between salt and umami. So these are the recommendations after we found all the things in the publications in the literature, is that we need to focus more on snack and condiments because those are very high salt containing food products, yet not researched much. So those are like the gap in the knowledge. As well as investigating more than just salt replacement. So if there's a combined strategy that you can have with salt replacement, that would be also a unique area, the gap in the knowledge. And then evaluating consumer perception outside of just the sensory context, because as the consumer labeling becomes widely evident to the consumers, they will see what ingredients are in the product. So not just the taste component, but the labeling context would be important to be investigated. And then a lot of the studies are focused on solid and semi-solid food. So there's more need of liquid food research area. So these are the gap in the knowledge that we found as we wrote the recommendation or the literature review. Thank you. I was pressed for time. Sorry. Thank you.
All right, so thank you so much, Dr. Lee, for your very informative presentations. So maybe we may reduce our excessive sodium intake from this presentation, right? Do you agree? Yes, great. Okay, and next speaker, Dr. Nobuki Sakai, the professor in the Department of Psychology at Tohoku University in Japan. Actually, I had the chance to visit his lab last year. He has a very good, fascinating facility and research facility and environment condition, and I enjoyed his presentation and also his lab environment. I would like to invite him to this podium. Please join me in welcoming Dr. Sakai.
Thank you, Dr. Seo. I'm Nobuki Sakai from Tohoku University. I want to present some data of our own that shows attitude, consumers' attitude to salt reduction in Japanese university students. And also, we are struggling about the finding how to reduce salt in consumers, in Japanese consumers. So this is a tentative study. First of all, as you know, washoku, Japanese food, sounds you as a healthy food. But actually, we have many high-calorie foods that is easy over to the Western foods. For example, the unagi, kabayaki, or unadon, it includes 1,000 calories in a very small package of the bento. And over 60% of Japanese have or are killed by cancers or cerebrovascular disease. So, washoku is delicious, but it's not in case in foods, but in our brain. The deliciousness of washoku is in our brain. These are results of the questionnaire based on Japanese university students. The minute things I will present it again in the following session. But as you understand, these are Japanese university students, and these are Chinese university students, and this is Australian university student answered yes. That is based on a preceding study, but these results are gained by our own studies. In summary, Japanese do not care about the nutrients. They do not watch nutrition facts appeared in the food packages. Not anymore. Not any. They believe washoku as healthy without any reasons. So when I ask students, do you have healthy food? Yes, I do. I had Japanese washoku in this morning. But it does not have any reason or scientific findings. And also, to enhance the faint flavor of the raw materials or the components, we Japanese usually use salts. The average of dietary salt intake of Japanese is over 10 grams per day for each person. So we should cut our salt intakes in half. Can we reduce salt intake by ourselves? This is also a result of the questionnaire based on the behavior, eating behavior in Japanese university students. Japanese do not have any knowledge of or any positive attitude to any negative attitude to salt. So they like salt intaking in Japanese university students, especially in their parents or their grandparents have much more salt in their daily lives. So summary for salt reduction in Japan. Japanese people do not have enough knowledge about attitude to and behavioral practice to salt reduction. It is suggested that we should not wait till Japanese people start reducing their salt intake by themselves. So how can we nudge Japanese people into salt reduction? So we have experiments about how about replacing normal foods by low salt foods. In this experiment, we measured their brain responses using NIRS, near infrared spectroscopy, because the participants should drink some foods or soups. So EEG cannot detect the brain activation. Also, functional MRI is not fit for this purpose of the experiment. So we adapt meals as a tool. So this is the result of the behaviors. Participants evaluate the low salt soup as less salty and less palatable in blind conditions. And there are no effect of the packages. So all participants can detect only based on their flavors of the foods. Also, this figure depicts my comments. Participants can discriminate the salt of soup with their tongue, not eyes. So when we replace the package of the soup, the replacement have no effect on the evaluation of the taste of the soup. Also, there are completely apparent changes, especially in the forebrain, lateral side of the forebrain. So drinking low salt soup evoked responses in dorsal forebrain. That implies involvement of the cognitive system in their tasting of the low salt soup. So this is a summary of the experiment. Japanese university students discriminated the low salt soup from the traditional soup only by its flavor. The labeling did not have any significant effects on the evaluation and the brain responses. Appeal for salt reduction and distributing low salt foods are useless for reducing salt intake in Japan. It is because they do not concern about over-consuming of salt and do not prefer low salt foods. So we should make palatable low salt foods, but how? This is a current problem, research problem in our group. This is a conclusion in this presentation. Japanese people do not have enough knowledge about attitude to and behavioral practice to salt reduction. Appeal for salt reduction and distributing low salt foods are useless for reducing salt intake in Japan. Thus, we should use sensory nudges for reducing salt intake in Japanese people by replacing traditional foods with palatable low salt foods. Thank you very much.
Thank you, Dr. Sakai, for your interesting talk. I appreciate. And I would like to introduce next speaker, Dr. Mei Peng. She is a senior lecturer in the Department of Food Science at the University of Otago in New Zealand. I had a chance to talk about her research. Yeah, I know this is not a good topic for breakfast, but I had a chance to talk about some research today's breakfast. So it was very fascinating and I like it. So I believe you also enjoyed today's talk. So I would like to invite Dr. Mei Peng to the podium and please join me in welcoming Dr. Peng.
안녕하세요. That's one of the couple of words I have learned. So kia ora, I'm Mei Peng from University of Otago, Aotearoa, New Zealand. I'm delighted to be here to talk to you about my recent project using pregnancy as a natural model to study sensory science and also the linkage to food choices. So my research question I have wondered for a while is, do we have such thing called nutrition wisdom? So would our body actually could self-select nutrients or food that would keep us in a healthy condition? So that's been my fundamental question. And similar to lots of colleagues in sensory science, the first step is we study our family members. So I often observe my partner and my mom in particular, look at their food choices. And my partner
is a carbohydrates goer. Like if we travel together, those are the example of food that he would choose and eat. And my mom, on the other hand, is a meat lover, and she will eat meats at all time. And this is my daughter. She, on the other hand, has a much simpler palate, living on short-chain carbohydrates, aka sugar. So that made me wonder, we do have kind of a preference for macronutrients, and somehow we fit into that kind of eating habits. And in literature, if we look back, there is some classic literature. We can date it back to 1939. This is done by Clara Davis, published in 1939. She did this very ambitious and challenging project that tracked 15 babies from the age of weaning, so when they stop breastfeeding, to up to 4.5 years. And during this time, she gave the babies free access to 33 types of food items. And that's completely free. It depends on them to choose. So there's no nutritional knowledge, unless the baby is super smart. So they just self-selecting this, and during this period of time, the babies were regularly assessed by nutritional status, growth and development and all that. And the key finding from her very ambitious and very cool projects is that those babies were able to maintain a healthy nutritional status during the 4.5 years by themselves. So if you could, based on her findings, if we could entertain the idea that we do have nutrition wisdom, and that potentially linked to our personalized food choices, what would be the mechanism? The synthesis comes into mind. So in the last few years, my group has done a series of studies. This is an example of what we do with the help from my graduate students. So we have done quite a few studies that are recruiting a group of people and then assess their sense of smell and taste, and then also assess their food choices. And typically, we use clustering analysis or statistical analysis to cluster people, so we can see the difference between you and me and to other people, right? And then we link those kind of differences in terms of energy intake, food preference, so on and so forth. I'd like to draw your attention to this particular paper that we published last year. I think that's linked to the point that I was going on about. So with this paper, we wanted to look at whether there's a differentiation between people in terms of macronutrient choice. So we did a clustering analysis based on the dietary records. So people fill out a food diary, and then we look at their macronutrients intake and composition. And we see 3 clear clusters, which is very interesting. So like people who has more, whose diet is more dominant in carbohydrates, and people who are more to the fat and protein. And the next thing we've also done alongside is look at the sense of smell and taste and evaluated their sensitivities. With the smell, which is a little thing on the left, we found no significant difference across the 3 clusters. But with taste, we did find a significant difference for MSG and dairy fat, suggesting people who has lower sensitivities to MSG and dairy fat, they had a less consumption of those macronutrients groups. But with those kind of work, we did quite a few of the similar studies. Of course, it comes to mind, what is the cause and what is the effect? Is the sensory sensitivities the cause or the effect? And I've been wondering that questions and not sure how do we address that. And who shall come to my rescue? My daughter again. So in 2019, I went through the pregnancy process myself, and I found this process fascinating. I personally experienced the major sensory changes and also major food choice changes. So I thought, okay, I'll look into pregnancy and see what pregnancy actually does to our bodies. So in classic literature, we can see there's lots of physiological literature suggesting that the energy demands during pregnancy changes significantly and very reliably. This curve is almost can be replicated in every woman, and also reproductive hormones changes at all time. So this creates this dynamic model for us to be able to learning to study sensory and food choice shiftings. So with that in mind, I proposed a grant and received the grant from Marsden Fund New Zealand to track 120 women, with half of them had no plan of having a baby in recent years, but half of them has a plan of having a baby. So we had these two cohorts. Our ambitious plan is to track them across several years, look at the 6 time points before pregnancy to postpartum. And those are the measures that we measure. This reference here is the protocol paper that we have published a few years ago. I'll just briefly talk about methods. With the sensory measures, we use the established methods from my lab. So we look at suprathreshold sensitivities and then using D prime as a quantification. And we also study liking and intensity perception of simple sensory compounds. With the food choices, so we use several different types of methods, including habitual method, like we ask people to record what they eat, and then also some cognitive methods and also some behavioral methods. So getting them into the lab, actually provide food and see what happens. And alongside, we also ask the woman to perform, to undertake a functional MRI task. But because they couldn't do it during pregnancy, so we do it before pregnancy and postpartum. So during this task, we are able to scan their brains and locate their brain activities while they are performing a food choice task based on pictures. We're also checking a few physiological measures, including metabolic rates, just looking at their energy demands during the pregnancy period, along with the adiposity and plasma measures of hormones and also access to their clinical records, which has been helpful. I'm just going to go show you a snapshot of the findings that we got so far. This is the preliminary findings of just the cognitive task. So what I'm showing you here is looking at macronutrients preference. So each person is performing a task looking at a computer screen and with a pair of foods with dominating macronutrients groups, and then their job is to choose which one they prefer. They do see quite a lot of them, but I guess in the interest of time, I'm just going to show you roughly what we found. So with the non-pregnant group, we see fairly equal distributions of their preference to macronutrient groups. So fats, protein, and carbohydrates, they kind of equally distributed. But if we look at the pregnant woman, there's a shift from protein to carbohydrates. So there's a bigger cluster around the protein, bigger cluster of carbohydrates liking. And this result has been echoed by habitual methods. So we're looking at their food records and it also says similar things. At least at early pregnancy, we think there's an increased preference to carbohydrates. And we also did the sensory, of course. We did the sensory assessment and looking at the changes in terms of sensitivities. With smell, we didn't find a significant difference. So at time point 2, which means the early pregnancy, but we did find significant reduction in sensitivities in taste. So for all 3 tastes that we checked, which is sucrose, MSG, and also dairy fat, we did find a significant reduction in their sensitivity, which has been really interesting. And a slight difference in liking as well. There's a drop of sweetness and increase of saltiness. And that's all the results I'm going to show here. But the conclusion that we got so far is pregnancy has been a very useful model in terms of capturing this shifting dynamic between food choices, senses, and also some cognitive changes. So with that, I would like to say 감사합니다 and kia ora. I'd like to acknowledge my lab and also my founding body, and also thanks for COPS for this opportunity. Thank you.
Next speaker is Tatsu Kobayakawa. He's Chief Senior Researcher of Human Informatics and Interaction Research Institute at National Institute of Advanced Industrial Science and Technology. Please welcome Dr. Kobayakawa.
Hi, everyone. Good afternoon. Konnichiwa. 안녕하세요. I'm sincerely appreciate to Dr. So and Dr. Lee to join this conference. I was much impressed of this conference. Oh. That's all? Okay. Today's my topic is like this. Yes. How we can recognize taste through our sense of taste and smell. And we use the ERP measurements during the simultaneous judgment tasks of taste and smell simulation. Okay. This is my questions before these topics. When we talk, for example, each other, we move partner's mouth moving and hear the voice, and then we recognize, oh, this person now talking to me, and time gap of vision signal or audio signal is almost none, almost simultaneous. But please imagine during my food behavior, in your eating behavior, timing of gustation inside of mouth and olfaction caused by recognized smell flow are not always temporally consistent. So because we take food in your mouth and chew, and then we feel the taste from our tongue. But recognized aroma flow will occur after that. It's simultaneously it's synchronously our respiration. So, to tell the truth, the timing and the taste gustation information and the olfaction information have some time gap. And in that case, we have to consider about the familiarity of the taste and smell combination. Sorry. Combination. That is, one is familiar combination, so we use soy sauce headspace, that is olfaction, and sodium chloride solution. And in the case of unfamiliar condition, kumari, that is cherry leaf smell, and sodium chloride solution. Of course, this soy sauce and sodium chloride is, of course, soy sauce is a salty food, so this is match condition, and unfamiliar means that leaf smell and the sodium chloride, and this condition are mismatched. And I will explain our simultaneous judgment task. Yes, please. Blue circle means taste, and red circle is smell. And this is just a fixation point. And please see. Yes. Now you can see taste and smell is presented to us simultaneously. So that is physically simultaneous presentation of smell and taste. Next. Like this. Of course, first taste presented, and after that smell was presented. So the first taste, 0.5 seconds after taste, smell was presented. Also, that repeats. And this is devices that is performed in this experiment. This is olfactometer, and the base developed in the German group. It's a female group, and this is taste stimulator that is developed by our groups. As experimental condition is like this. So after that I will explain, but somehow, for example, 10,000 smell taste is first we stimulate the participants smell, and after that, after 1 second, 1,000 milliseconds after, I stimulated the taste stimulation. And that is our condition. So very large gap and the two very small and no temporal difference, exactly 0 milliseconds will perform. And somehow these are developed by my research. Okay. And this is a result of our one example. So I will explain how figure means. Okay, this particular line is 0 to 1. This is probability. Probability of participants judging, oh, this smell and taste combination comes to me simultaneously. And of course, this is almost 0. So the probability is gets highest. But if the gap is getting bigger, of course, in this case, okay, in this case, for about 400 milliseconds. In this case, 400 milliseconds. This is olfactory first. So first olfactory, and after 400 milliseconds, taste is coming. In that case, 40% examples, participants judge these are different, separately stimuli. So this is the example of not so smell and taste, but vision and audition. This is from other research reports. In that case, this width of this distribution is very narrow, but this is smell and taste. The difference we can see the difference. The of course is sharp and this is broad. And this is result of familiar and unfamiliar condition. Familiar means soy sauce, head space, and sodium chloride. Unfamiliar is cherry blossom leaf and sodium chloride. You can see the broadness is much broader. This unfamiliar condition, but familiar condition is much broader. So familiar condition, soy sauce flavor, sodium chloride had lower temporal resolution than unfamiliar conditions. Okay, and so first discussion, familiar condition had lower temporal resolution than unfamiliar condition. That is the hypothesis. Intentionally suppress onset perception in order to form flavor subjects or objects. So to clear this hypothesis, we measure the evaluated potentials. Evaluated potentials for gustation and olfaction. Okay, this is the result. First, I show you the another experiment results that is just no task evaluated potential of olfaction. And this is average signal average. That is participants judge these combination feel separated between the smell stimulation and the taste stimulation. As this red line is same. Sorry. Yes. These are all the same time. The participants judge. This is average signal of participants judge this combination of smell and taste coming to me almost at same time. And in that case, in this latency, we don't have any difference among three conditions. But in this case of the gas-driven related potential, and this is same of the olfactory condition. This is no task, just presents that is a sodium chloride presentation, and this is average signal. And this, the blue line is separated. The participants feel the combination of the smell and the taste different timings. And these are average signal of participants judged the combination of the smell and that is 120 milliseconds after onset of the taste simulation. We can find significant difference between these blue line and red line. And red line is significantly reduced compared than separately feelings. So the latency of this one is we call it usually P1. P means positive and the one is the first component. And in our previous MEG experiments, this P1 component goes from the primary cathedral area, that is intracortex and central part of operculus. And so for me it's very surprising because first we didn't perceive this very fast and primary activation usually did not affected by any conditions, but in this case significantly reduced. So if we have the hypothesis, maybe these neural pathways. So of course this is primary cathedral area, but if we of course the reduce of the amplitude is occurred in this area. So this means this part or before primary cathedral area was affected by same time or not same time conditions. So we guess this maybe of course just a hypothesis or a guess, but thalamus is affected to this primary cathedral area. So of course we don't confirm, but we don't confirm this thalamus activation, not yet. But this is my hypothesis now. So conclusion: temporal resolution of simultaneously judgment because lower familiar condition is unfamiliar condition. And this phenomenon could be caused by decline onset representation in PGA, at least. So this decline of onset implies some interaction of gas station and olfaction in the thalamus. So implied not only in the higher cortical areas. Thank you for your attention.
We'll take 5 minutes break, and so please be back by 3:27. So 27 after 3. 5분 동안 휴식하고 3시 27분에 다시 시작하도록 하겠습니다. Okay, so we'll resume. Our next speaker, Dr. Paul Smith, is a senior researcher of the Agrotechnology and Food Sciences, Human Nutrition and Health Program. He is affiliated with Wageningen University and Research. Please welcome Dr. Smith.
Yeah, good afternoon. It's my pleasure to speak here today. Bear with me, I will go quick over some slides to abide by the strict time limit. So this is the basis. If you look at eating behavior, the eating cycle is the basis. So this is a simplified version of John Blondell's satiety cascade. But in essence, it's governed by the decisions of what to eat, when to start eating, the meal initiation, and when to stop eating, the meal termination. And these decisions, whether they're taken consciously or more unconsciously, are governed by the brain. In the brain, all these factors, it has been noticed before, this eating behavior is very complex. And all this complexity kind of converges in the brain. And there it's all weighed, and ultimately this results in some eating behavior. Now, one way to look into the brain, which was not possible before, is functional MRI, and the most common form is Bolt fMRI. And what that provides you with is an indirect measure of the signal in the capillary brain vessels, and that signal is inversely related to the concentration of deoxyhemoglobin. So you have an endogenous tracer, basically. And the key thing is that this oxygen concentration is coupled to the changes in neuronal activity. So it's an indirect measure, but it works. It's been used for decades by now, and you can use it. But it requires careful experimental design to be able to make sensible conclusions. This is, I think, a classic study that I often use as an example. Unlike the Japanese student that were not affected by labeling, we see something different here. So this is a study with 3 wines, and they are presented as 5 wines. If people rate the wines without any label, the same wine has a similar liking rating. If you then attach a price to the bottle of wine, this affects the subjective experience. So if you say the wine is more expensive, people will like it more. So it's a cheap way, if you bring a bottle of wine for a friend, to have a higher liking. Just tell them it's an expensive bottle. Now, people also tasted these wines in the scanner, and then they showed that you can see a different signal just depending on the price label. So it's a purely cognitive effect. It's the same wine, but you see a different brain activation. And this is in the ventromedial part of the prefrontal cortex, and we know this area encodes the liking. So you could say this is a very expensive way of measuring a difference in liking, because we already know the liking difference. So in that sense, you could say it's a no-brainer. We're just measuring what we can see in the subjective rating. So maybe this is not the most interesting use, you could say, of functional neuroimaging, but it does show the link. So more interesting is, I think, if you can link it also to the behavior of people. So this is one example of a study we did. In this study, people taste different drinks, and they get one of the drinks after the scan session. So this is taste fMRI. And here we found a negative correlation between the taste activation and the subsequent ad libitum consumption of that drink. And the correlation was pretty strong, around 0.7. And surprisingly enough, the subjective ratings of the liking, for example, did not correlate with intake. And this is just an example of the more broader idea that neuroimaging may provide a more objective way of, or more accurate way of measuring food motivation, than a self-report measure. We can discuss later about how far this holds. So now I would like to move to other types of designs. So giving a food or a smell, or showing people pictures, or you could say passive designs. It's cue reactivity. You can also ask people to do a task. And the most commonly used task is a food choice task. This design, it's common in decision neuroscience to use single item food choices. And in this task, people make about 150 food choices for single items. But they are asked to consider something when doing this. So either the healthiness, which is the health block, the tastiness, or they're asked not to have any specific consideration. And we adapted this task, we simplified it a bit to use it in adults and also in children. And basically this task, it works. We replicate ourselves and we replicate Todd Hare's result. And this is one of the things that comes out of it. The nice thing is of a food choice task that in addition to the fMRI, you get behavioral data. You get the choices people make and also the reaction times. And before the task, all the food pictures are rated. And as everybody knows, I think, taste is key. So the best predictor by far of what people choose is their taste rating. And then, you see health, it's significant, but the effect size is a lot smaller. And what we found in this study is that this effect of the health rating is different between children and their parents. And I didn't show it, but in both cases, if you ask the participants to consider the healthiness, this does affect their choice behavior and it does affect the brain activation for both groups. And this is just teasing out this effect of the health rating, so the perceived healthiness, and how it differs between children and adults in this case. And it shows that fMRI can be used to look at these choice processes and how they are influenced, perhaps differentially in different groups of people, and how this could be affected by an intervention, in this case a very simple cognitive instruction. And then to finish off, I want to show another example. This is an example around sort of the classical dilemma between the immediate gratification of a pleasurable food and a long-term health consequence. And there's a theory, it's a psychological theory around self-control, that this situation will involve a conflict between this long-term goal, in this case a weight-watching goal, and this immediate seduction of palatable food. So we did a study in young women that were lean, and they had a weight control goal. They had high dietary restraint. And they made food choices that were manipulated based on their individual ratings of food pairs. So either the pairs were matched in liking, then it's easy to choose the low energy version, or they were not matched. So then you have the more natural situation where the high energy food is also more liked. And then you have to exercise self-control to choose the healthier option or the low energy option. Now in all the measures that we took, this is the fMRI, and this is an area involved in conflict monitoring. If anything, in the self-control trials, there's less activation instead of more. And also in the other implicit measures, the reaction time and the eye tracking measures that we took at the same time, everything points in the same direction. There's no evidence of any self-control happening. So these implicit measures are all congruent, I was actually amazed. It hardly ever happens that we have so consistent data. And it shows that in this population, in this case, apparently there was no conflict happening. And this was actually reflected in the choices because people chose only 20% of the low energy snacks in the self-controlled trial. So they were utterly failing in exercising self-control. So in this case, yeah, that appeared due to a lack of conflict instead of an inability to act on this cognitive conflict. So to wrap this up, I think functional brain imaging can be used to study the neurocorrelates of food perception, also food reward and eating behavior. I have to say there's a lot of room for confounding. It's food and it's functional neuroimaging, so both are prone to many confounding factors. We have a complex research domain, and that's why you need very careful experimental design and preferably a good a priori brain-based hypothesis. And I strongly believe that it's most useful to use these techniques if you can combine it with real-life outcomes, like behavioral outcomes, and then you can get more out of it. And so I do think they can provide more sensory or consumer insight or insight into food regulation of food intake, and that could inform interventions like nudging interventions or other types of interventions that are aimed at promoting healthier eating behaviors. So this concludes my talk. Thank you for your attention.
Okay, our next speaker is Dr. John Kapchura. He is Research Fellow at CompuSense. He also served as Vice President of Innovation, Research and Development at the same company. John.
Okay, so the title of my talk today is Using Component Methods to Explore the Variability of Sensory Perceptions. In sensory evaluation, we have human assessors who are evaluating products using an experimental design. And a key part of this is collecting the right data. But another key part of it is analyzing that data in an appropriate way. So I spend time working on both the methodology side in terms of data collection and data quality, as well as on the analysis of that data, a field that we call sensometrics. And one of the types of data that you collect, that people in our field collect, are data from trained assessors who conduct sensory descriptive analysis. And so these are intensity, they're measuring the intensities of attributes, multiple attributes that are correlated for multiple products, often evaluated in replicate. And so one of the things that's often done is that data are aggregated into a data matrix with products in rows and attributes in columns. And the reason for that is that we're interested in the products. And so what do you do when you have sort of these complex relationships embedded in a matrix and you're a statistician? And the answer is you make more matrices. So often what happens is that principal component analysis is collected. The data are decomposed into two matrices, a score matrix, which is shown here in blue, which is denoted T, and a loading matrix, P, which is shown in red. And multiplying the scores times the transposed loadings gives you the data. But these components that are in columns have special properties. Not only are they uncorrelated, but they're also extracting variance maximally in successive components, meaning that we only really need to look at the first few components often in order to understand and get a summary understanding of the bigger picture. And so we could do a dimension reduction to only a few principal components, shown here, where the truncated scores multiplied by the transposed truncated loadings approximate the data. And often the data lends itself to visualization. And so often you'll see people looking at the configuration of scores, which are products shown in as alphabet letters, and the attributes are shown, and you can interpret these products in reference to the original attributes. And there's other component-based methods that are available, principal component regression and partial least squares regression, where you can use explanatory variables in order to explain or predict response variables, such as when you have chemometric data and you're looking to use that data to understand how products are perceived. And so why use these methods at all? They're useful for summarizing and visualizing complicated data. There's often relatively few underlying sources of variation that get captured in these components. And the components provide a useful approximation of the data, in part because they're separating signal and noise. You can think of the components that you're retaining as being signal and the components that you're setting aside as being noise. Now you're able to look at this configuration and see outliers very easily. And you can use these approaches in order to confirm hypotheses as well as to generate new hypotheses. And one of the things that's very useful and not done quite as often is to visualize the uncertainty around these products or objects after principal component analysis or other component-based methods. And so you could think of sort of a cloud of uncertainty or variability around these points, and then you can think of an approximation of that, in this sort of multidimensional space. And these sort of regular-shaped approximations, such as an ellipsoid, would allow you to calculate a volume in order to numerically quantify the uncertainty. And so here you're able to not only see your typical PCA biplot, but now the variability around the points. Because you would probably interpret this differently if it looked like this versus if it looked like this versus if it looked like this. You'd come away with very different conclusions. And also, in an analysis like that, often we think about it as investigating objects. But in fact, implicitly, we're also often investigating differences between objects. We're saying something about product A being different from product B in some particular way. And so it's useful not only to look at these original objects, but also paired comparisons of objects within the same space. And so here, you would interpret the difference between these two products, A and H, differently depending on if the underlying variability looked like this, or if it looked like this, or if it looked like this. You'd come away with a different interpretation. But in some cases, and I would say actually, fairly often in sensory evaluation, we have a special case. We have a case where we have one product that's special in some way. It's a gold standard, or a market leader, or a reference product of some sort. And then we have other products that are test products that might be prototypes. If we're looking to compare the products, what's typically done in PCA, for instance, and other component-based methods, is to look at all paired comparisons, which is implicit in the way that you're analyzing the results in a conventional analysis. But if you can refocus the analysis on the paired comparisons that are of interest, where you're only focusing on the particular pairs that comparisons that you want to make, you come away with a much more efficient and effective analysis. And it can be shown that if you look at all paired comparisons, you're really extracting only a subset of the available signal that's extracted if you focus on the relevant pairs. And so what I've shown you today are different approaches that can improve on standard practice. So there are techniques for visualizing and quantifying uncertainty. These techniques can be used in order to screen results numerically. so that you can have an automatic screening of the paired comparisons in order to find, to draw attention to differences between products that might otherwise go unnoticed if you were relying entirely on a visual interpretation. And having the ability to identify a priori, what is it that's relevant to you, and focus your analysis on that, you get a better result. So you can focus on the relevant paired comparisons to get improved signal extraction. Here are some selected references of the material, which I look forward to discussing in more detail in the coming days, in the discussion afterwards and in the coming days. And that's my talk. Thank you.
Our last speaker today is Dr. Janet Wang. She is Associate Professor of Department of Food Science at University of Copenhagen. Janet?
Thank you, everyone. Let me move this a little bit. There we go. So first of all, I would like to thank the organizers for inviting me to the BrainLink X Lab Day events. It's a great pleasure to be here. And I would also like to thank you guys for the opportunity to talk about something that's quite close to my heart. So my background is not in food science, it's in computer science and experimental psychology. So I wanted to take this opportunity to have a little bit of reflection on the use of machine learning, both in current uses and also a little bit of a reflection on the future. Machine learning, as we all know, is a very hot topic these days. I did a very casual literature search on Web of Science just to show you the increasing number of publications in recent years that deal with both machine learning and sensory and consumer science. But what exactly is machine learning? So before we start, I wanted to give you my definition of machine learning so we're on the same page. And in very simple words, it is the process of learning from data. And I have some graphical illustrations. So traditionally, if you ever studied computer science, say, and you learned about algorithms, what happens is that we have data and we have known rules, and then we make models, we make algorithms that combine the data and the rules to give us answers. Machine learning turns this, let's say, on its head. What happens is that we have data, we have some subset of answers sometimes, and what we use the machine learning model for is to figure out the rules that would connect the data with the answers. So it's a very different way of thinking. So machine learning would approximate the underlying data distribution and to figure out perhaps some complex patterns that is otherwise hard to figure out from rule-based methods. And more importantly, and this is really the one takeaway message from my talk, we are learning from data, so both the good things and the bad things from the data are learned. So curating your data is extremely important. And this really ties in what Sarah was saying in the beginning about data quality. I will come to that point later. So what kind of data do we usually work with in sensory and consumer science if we're talking about learning from data? Well, this is not a, let's say, an exclusive list. It's some things I thought of. We can work with chemical data, sensory, consumer data, some biometrics. I'm happy we had both the EEG and the MRI talk before. And I work a lot with, let's say, digital internet data as well. And a little bit of a data flow of how we tend to use these kind of data. I would say that typically we would start with, let's say, chemical or biometric or internet data, and we can use machine learning to maybe try to predict sensory data, and all of this can be used to predict consumer data. And I'm saying this is a typical overflow of how we're using machine learning today. I wanted to present you with a few case studies of current work just to help demonstrate this idea of learning from data. So I chose 4 kind of varying examples just to give you a picture. On the talk on Thursday, I'll go more into detail. The first example I have has to do with natural language learning. So for all the studies, I will use this model I have here. So where I'll present to you in the study, what is the data they use, what is the answers they trained the data on, and why is this important. So in this case, they were looking at whiskey reviews published online with a lot of words. And what they use machine learning for is to basically automatically extract the words that are descriptors. And the answers they provided the machine learning model were some human tagged descriptor words, as you can see here. And the most important takeaway point here is, why the hell should we use machine learning? And this is the green box that we'll provide in every case study. In this case, it is time-consuming and expensive to build a flavor language for a new product or category. Usually, traditionally, you have to use a sensory panel. Sensory panels are expensive, it takes time. In this case, they took existing whiskey reviews online and used machine learning to quickly figure out the relevant vocabulary. A second case example had to do with sentiment analysis. In this case, this was a free jar approach. So they had consumers rate, kind of in their own words, why a particular product was good or not good. So here the data was free text, for example, this is too sweet or this is not creamy enough. And the answer in this case was that consumers also gave the category, gave the product 3 hedonic categories. They either liked it or didn't like it or liked it very much. And here the machine learning model learned to associate the different words, like too sweet or not creamy, with kind of hedonic drivers of liking. So you ended up with the rules being really helpful. I realized this graph is really small, but basically they could figure out which descriptors had which weights on liking. So which kind of consumers really liked something like sweetness or creaminess, and which kind of consumers really didn't like some things, like, for example, too salty. So in this case, this approach was important because it identified drivers of consumer liking, but you didn't have to kind of train people to use a set of vocabulary. Rather, consumers could kind of be very free and spontaneous. So this was basically, it's another way to save money and to save time. A third topic, this is topic modeling. In this case, this was using digital data. They took about 20,000 tweets to study the different use cases for turmeric. And in this case, there was no answers provided because we were looking at unsupervised learning or segmentation. And here were some brief results where the automatic topic modeling found 6 most common, let's say, subjects involving turmeric. And in this case, it was a useful method to use because it's very time-consuming and expensive to run a large-scale consumer test. And instead, they could just scrape Twitter and use these automated methods. And my last case study was very interesting because it combines both chemical and sensory and preference, in this case with beer flavor prediction. So in this case, the data were chemical compounds from 250 different types of beer, and the answers that the machine learning model learned was both sensory features and also consumer preference. So let me just skip a little bit to this part. So it was useful because otherwise it would be very expensive and time-consuming to figure out which chemical compounds taste like what, and which kind of sensory features do people like. So they were able to use machine learning to figure out which kind of chemical compounds lead to consumer appreciation. And they were able to do a validation study where they actually adulterated specific beers with the machine learning produced chemicals, and they were able to see that people actually liked the beers more using the chemical compounds determined from machine learning. So I really appreciate this study because they went full on through the model validation. So I want to also go through some challenges of machine learning. You know, it's not all rainbows and unicorns. For me, the biggest challenge in sensory and consumer is that there's really a lack of ground truth because it's quite expensive and time-consuming to get these sensory or consumer data that we can train the machine algorithms on. And also, our ground truth are maybe not so much ground truth, but because as we know, human perception is variable and it's subject to contextual effects. So unlike many other subject areas, machine learning in sensory and consumer science is especially difficult because these kind of ground truths are so hard to get. And of course, we have these general challenges like trustability. Machine learning algorithms are kind of black boxes. And very often both consumers and people using the algorithms have trouble trusting it, and this is why interpretability is such a big area right now in machine learning. Like I mentioned before, data quality and any inherent biases we have in the data, which is also linked to ethics, especially when we're using a lot of digital data. What are the kind of data protection privacy issues, and also are we getting data from the right people to be truly diverse and representative? There's also a large carbon footprint involved in training these large models. And finally, I want to mention this kind of obsession with machine learning. Are we really kicking humans out of the loop, and are we losing expertise that humans are uniquely good at? And this ties into the kind of future direction I'm interested in. I spent 1 year in 2022 also working for the Center for Hybrid Intelligence in the Aarhus University Department of Management, and we were really thinking about the problem of how to get humans and machines to work together instead of just kicking humans out of the loop and only focusing on machines. So I would like to invite everyone to think about in which aspects are humans actually uniquely good in the world of sensory and consumer science. I mentioned this as a wine expert, so I have my own prejudices. So I just want to show one example where if we're talking about olfaction, humans and machines are good in olfaction in different ways. For the sake of time, I'll just kind of wrap up my message, which is to say, I think here a lot of future opportunities lie in, instead of just replacing humans by machines, how can we figure out ways to make humans and machines work together? And in summary, machine learning is the process of learning from data. Currently, I showed some cases where there's both supervised and unsupervised learning, and the point here is to both save time and money to help predict human perception and preference. That said, sensory and consumer science really face kind of very unique challenges regarding the availability and quality of training data we have. And one challenge, I think, is how best to keep humans in the loop instead of kicking them out altogether. I think in the future, one thing that we haven't really done yet is how do we make personalized predictions, maybe perhaps via reinforcement learning. And something I'll talk more about on Thursday is I'm very interested in pedagogical considerations. How do we best teach sensory and consumer science to the next generation that keeps machine learning in mind? So thank you very much for your attention.
Thank you to our invited speakers for a nice talk. We will invite them on the stage, but we need to set up the chairs because we don't want to stand and talk for question and answers. And so in the floor, please prepare your questions. You can think about what you want to ask, or what was the interesting things that you learned today that you want to know more, because most of the audience here are not invited for our XLab Day conference, and so they may want to know a little bit more from the presentations today. And maybe we need to turn off the screen. Let's see what's the. 네. 그리고 그러면은 이거 그대로 하면 돼요. Okay, now we are ready. Very quickly, we will invite all speakers on stage for questions and answers and for further discussion. Please. Okay, please raise your hand if you have any questions. And address yourself, who you are.
To break the ice, maybe let me start with quick questions to all speakers. So today is July 8th, 2024, and outside is very hot, right? So I like eating ice cream. So I want to see what kind of flavor in your ice cream. What is your favorite ice cream flavors? Let's start with these simple questions. Okay. Do you have any favorite flavors in ice cream?
Yes, I do.
Yes.
Should I use it? I really thought you were going to ask some sort of like methodological question. Actually, I will just make a short plug for one of my research questions because I study flavor creativity. So I have a flavor creativity test where I ask people to come up with flavor pairings. So like for chocolate ice cream. So it has to be chocolate plus something. And I can say that one of the most strange flavor pairings I've gotten from my studies is chocolate and garlic ice cream. Garlic.
Wow. Well, I like vanilla.
I'm restricted to the sugar-based ice, so no milk. And I also make my own ice cream, but the one that's hard to make and that I like the most is a lemon ice cream. Yeah.
Yes, I love chocolate, so my favorite flavor is a chocolate sparrow.
I had to think. I'm an ice cream lover, so I eat all flavors. I'm not picky. But if I have to choose one, it's probably Hokey Pokey. It's a very New Zealand thing. So it's a honeycomb. So it's like dried honey. It's crunchy, and they put in ice cream, and then you crunch, crunch, crunch. You should try it if you have an opportunity.
My favorite flavor is vanilla. That is a very orthodox, and the major flavor in Japan is vanilla. So children start eat ice cream with vanilla flavor. So my research hypothesis is no. that is not so classical traditional. The deliciousness, palatability is in our brain, especially in our memory. So my favorite flavor is vanilla because it is based on my memory. The small children and very happy and having no stress. So I remember all that easy living with the flavor of vanilla.
I have a theory of vanilla. As a food scientist, vanilla ice cream actually is the highest quality ice cream because you can't fake it. So chocolate ice cream usually is made with the lowest quality milk versus vanilla ice cream is made out of highest quality milk. Yes. I actually don't eat ice cream much, but in our Washington State University School of Food Science, we have a creamery that makes this amazing cheese that's canned. It's called Cougar Gold, and so it's shipped to a lot of different embassies, U.S. embassies, because it's canned cheese. And originally I thought, oh, canned cheese. It's like Cool Whip, or, it's very processed, but it's actually an amazing sharp cheddar. In the creamery, we make ice cream, which I think is the best, although I don't eat ice cream much. And they have a very localized flavor that everyone loves. It's huckleberry flavor. So that I don't eat ice cream, but I think that's the most popular in the state of Washington.
Thank
you. May I had you pegged for Goody Goody Gumdrops as your favorite flavor. So I lived in New Zealand also, and Goody Goody Gumdrops is light blue Turkish color aimed at children with wine gums in it. But since May loves everything, I thought that might have been one of your favorites.
That's probably the one I don't like.
Anyway, I have to choose the ice cream that goes with the national pairing in Denmark, which is salty licorice flavor, and that's not for the faint-hearted.
I like many ice creams, but if I have to choose, I love root beer float. So vanilla ice cream, but in Korea we don't have root beer. So when I went to Japan, I bought 2 bottles of root beer, glass bottles, and I brought them back so I can have root beer float. So
My favorite is mint chocolate. Yes. So, oh, thank you. Because whenever I say I like a mint chocolate, they say, oh no. But I like mint chocolate because it gives me some kind of refreshment and also sometimes energy. So that's why I like mint chocolate. Okay, thank you for your nice answers. It's very interesting with theories and also scientific background. Thank you. Yes. There is any microphone? Yes.
This is Haesung Lee from Ewha Women's University. Thank you so much for a wonderful introduction of various topics. I think Sarah started the big question of the sensory science, past, present, and future. So opening up the big topic for us to discuss over 3 days. We will be very busy talking about many things. And many speakers talked about like from chemical senses to food behavior, different methodologies and different research questions. And actually, John is actually coming back to the question, the sensory science, how we should continue to produce the quality data and be useful to basic science. So now my question would be, what would be the kind of basic research discipline? I know this is multidisciplinary approach, but many of us are also working as a professor in the department relevant to food science or food and nutrition, and also the sensometrics, of course, becoming very important in our field. And what would be like kind of a real core science within this sensory science in food science area? Can you recommend any kind of a course or most relevant basic science training relevant to sensory science for the future?
No, I can't recommend a single course because I think from my perspective, the field is very, very diverse. I think if you are primarily interested in sensory science and have a product focus, then I think that the more traditional sensory science and technology fields, are a good place to come in. And actually the surveys that we have from people, for example, attending Pangborn, we know that there is a dominance of people with that background within the community. Close to sort of 65-70% of people that today work globally in sensory and consumer science that attend a conference like the Pangborn Symposium come from this type of discipline. I think if you're more interested in consumer behavior, food-related consumer behavior, I think some sort of background that provides you towards the social sciences, be it psychology, marketing, some economics, some sociology, anthropology, something that helps you understand about how people behave and think. I would strongly recommend. And then as you say yourself, the 2 other elements that I think are very important is research methods training and for many people that would include some sort of quantitative or statistics, but quantitative methodology. So I don't know if that answers your question, but that's a good starting point, I think.
Oh, we have to, all of us have to answer?
No.
Actually, that's, I really like the way you addressed it. I was like, oh, one course, what would it be? I was like, I don't know if I can actually come up with one course. I don't think there is just one course that we can recommend, but there are many courses that are very foundational that's already existing, namely in the textbooks, so we don't have to think about those that are already established. I do think that the up-and-coming area of research that has been presented, and I agree with neuroimaging and machine learning, artificial intelligence, those are the areas that are up-and-coming and will be highly beneficial. And I really like, sorry, the last, Janice's presentation, in that we try to resolve issues when we think about up-and-coming research in any area. And the issues that we always have conversed in sensory science is that we use human subjects, which are subjective in nature. I always argue in that, though, so subjectivity and objectivity, but any subjective in nature and also time-consuming. And so the time-consuming part of it can be overcome by a lot of that machine learning, artificial intelligence type of exploratory research, as well as it is also very time-consuming to collect the data to create that model too. So there's that. But I do think that data analytics leading to artificial intelligence is one of the newer area that I'm not familiar with. So if there's a course on that, I would love to take.
That is a very difficult question, but the food science is a very obvious goal directly academic research areas. So it can be very useful to convergence many disciplines for the goal directly behaviors. So now I'm a director of the research center, Advanced Research Institute for Sogochi Informatics. Sogochi is a Japanese word. That means convergence knowledge. Our research institute aimed to do some research which integrate many disciplines to some goal. So the output is very important for us. So for the goal achievement, we gather with our knowledge to convergent, to develop a way to the goal. So the integration of the knowledge is the best course for food science. I think you have already some disciplines. For example, the chemical sciences and the physiological sciences, and also economics, and also have human behavior or consumer behavior. But I think it is parallelly organized. So I recommend you to integrate. So I recommend you to have a course for integration of the science. So that is not easy, but it should be earned, especially in the young scientist. That is my recommendation.
Can I just say I agree with everything and pass it on? I think from my point of view, I see myself as an early career researcher. Like I have been in sensory field probably 10 years post PhD. Like over those 10 years, I have learned quite a lot. Like I have a background in experimental psychology, but I have over the course I have learned food science, some elements of food science. I have learned about neuroimaging recently. I have learned about sensometrics. I mean, I did psychophysics. But so I really think sensory is a dynamic field. But I think my point is, especially for our graduate students, I think if you're interested in sensory, it's just important to be asking the questions. What interests you? Is that salt reduction? Is that sugar reduction? Is that new product development? I think if you have a good passion, you have a strong passion and a strong reason to study something, there's plenty of opportunities to learn the skills and methods along the way. So I think that's my point, is let's ask some exciting questions and keep asking them. Thank you.
Yes, it's very difficult to answer. And Dr. Sakai have an opinion, and I almost agree with his opinion. Originally, I'm an engineering person, and my master course thesis documentation is working model using neural networks. And so since that is now about 30 years, so I'm always watching the tide trend of the food science or sensory science with that kind of the mathematical models view. And of course, the model, the behavior or sensory sensation is almost very non-linear phenomena. It is very difficult to solve from the mathematical method. So I have interest to such kind of behavior or humans economics. And somehow now is AI trend is maybe that is a third one. The first one, and my graduation time of the university is the second tide of the artificial intelligence. And of course, at that time, the peak of the second one and down, and then now third peaks. And third peaks is remarkable compared to the previous ones. And now, computer has very powerful, very big power to calculate, and many of the data. So we now the point of the next step with mathematical or nonlinear mathematics to using nonlinear mathematics, and then I hope we will be get the next step of the behaviors to foresee the human's behavior. But to perform this next step, we have to conjunct so many areas. But the areas which we can engage as one researcher is very small. So I think that it is very important to get together various kind of the field and together, and we have to one very important thing. So we have to yes, in that case is the difficulty of at the time the same word, but the definition is quite a difference among academic fields. So we have to first this vocabulary is this meaning, and then we have to go the next step. Somehow, in that case, we have to get together, of course, a scientific view of the, but additionally that we have to view of production or economy. I think that is my opinion. Thank you.
Yeah, I don't think I can add much to all that has been said. I'm not sure if you have brilliant answers that you're eager to tell. Otherwise, I would like to ask a question to Sarah. Unless you want to add to the first question.
Do you have any opinion?
Can I say one thing? Sorry, John. Was that I wanted to I have a really weird sense of humor, everyone should know. So I was going to be a little bit different from everyone and say that what's really important for sensory science is experimental psychology. Not only because I have a PhD in it, but I teach the sensory course in Copenhagen, and I feel like what's very important for students these days is to have flexibility and to be able to generalize across products. I always try to teach people sensory science is not just for food. You can use it for anything, any sort of product evaluation. And I feel like coming from food science might limit people to only think about what is edible. So I like psychology because then you can think about all the sensory inputs and all different types of things. So that's it.
Yeah, let me add one thing. Yes, so I definitely I agree with you. So I think, in my opinion, we need to go back to the origin. For example, like chemistry or basic science, like chemistry and mathematics and physics, we need to strengthen this kind of concepts and theories. And also, one person cannot study everything. So if I can be master in all kinds of sensory science, probably I should be 100 years old or more. So I think in addition to our knowledge or our scope, I think we need to strengthen like some subject about how to collaborate and how to communicate. How to communicate with different disciplines and researchers from different disciplines. So we need to strengthen how to communicate each other and how to deliver and how to accept other disciplines' opinions or concepts. I think that will be more effective and time effective and cost effective to collaborate and to enhance our creativity and also our like a scientific background. Yes. Any other thought? Yeah, if not, we can move on next questions. And yeah.
Can I ask a question too? Yeah, I was wondering, I was triggered by your find the definition of sensory and consumer science challenge, and I kind of, yeah, my brain couldn't converge to a solution in the past hour. So then I was wondering, could you maybe explain what is the need for a definition or a better definition? Because you seemed sort of dissatisfied with what you came up with. But I think you tried hard, and you're one of the experts. So why do we need it, or what? Yeah.
Many people, when we've sort of taken this idea and discussed, is there a need for a definition? We hear that question sometimes. Why do we need a definition? And I think within the community, there's probably not so much a need for a definition, but definitions are helpful when you are talking to others, and it's part of, I think, referring back to the communication issue, when you are collaborating with others, and for example, in Europe, we were very large multidisciplinary projects, with people from lots of different fields, so being able to define and explain, this is kind of where I belong, and I do believe that in teaching there's quite a large value. I mean, you start with an introductory course in sensory science or sensory and consumer science to actually be able to create some sort of boundaries around the field. And I think that's where we started with this challenge, simply observing that definition exists for sensory, but doesn't formally include the consumer area, which is the area in many parts that have been growing within the field.
I was really like, oh, yeah, revelation, because we're so in the discipline that we don't even think about that there is a need of definition. But when you mentioned, I was like, oh, wow, yes. Food science needs a definition, because people, when they say, oh, I am majoring in food science, immediately go to nutrition.
which is separate from food science. And so then people are like, oh, then dietetics? No, that's separate from food science. So then people ask them, what's food science? And the best way I describe it, and actually this is why there's a need for definition, is post-harvest of any raw ingredient, animal or plant, prior to consumption. So post-consumption is nutrition. Prior to harvest is crop science, animal science, right? So anything food related in between that spectrum, but that's also very limiting too. Sensory science is at the intersection of food science and nutrition almost, because it's during mastication, but also, and it encompasses all the data and human behavior, and then now you add on the consumer science. So it's a completely different discipline of its own. But it can be very limited when you look at that spectrum of intersection of food science and nutrition as well. So I think this is why the definition is needed, especially in the context of external, when you're trying to explain to external audience. But internally too, like we define ourselves, and that's why I thought, oh, revelation, yes, sensory and consumer science.
Thanks, and I agree with you. And just to add on to that, I think one of the challenges that we've seen in this work is actually coming up against a question that says, how broad should the field be? At some point, does the field become too broad? And for example, where should the boundaries sit? And so it's also this idea of how far do we want to go, or how narrow-minded, or do you want to be? So I think it's a conversation and a piece of work that helps create dialogue within the community, and that's probably value in its own sense.
I think another reason that we do need a definition is that there are definitions out there. There's the evoke, measure, analyze definition that's been around for a while. It came out of IFT, I think, in the 1960s, and I think that the field has moved on substantially from there. And so when we're trying to communicate to people, what is sensory science? There's a danger that they're going to go back to this very old definition. When I think that the way that sensory science is being used today in corporations, in order to, you can see even from the diversity of the talks here today, how it's being used. It's not just a matter of, evoke, measure, and analyze. It's something much, much broader than that.
We'll finish this in a tick, but just to add on to that, because I think the other part that we, in fact, decided to exclude from this is then what is the purpose of it? What are we trying to achieve? So you can say, are we trying to achieve better global health or population health? Are we trying to support towards greater sustainability? And that becomes a quite charged area. Then do you bring these some would say moral, ethical considerations into the definition, or do you leave that outside and then say, well, I can choose to do with the field or with my work in the field the way I want to do it? So there's many sort of nuances in the way that you look at this. Sorry.
Any other thought from the floor about these questions or topic? Okay, so, yeah.
I have a question for Janice on the machine learning, because I think where I am standing, I'm seeing something that is a hot topic. And I think, some of this idea of being very data-driven is not particularly far from some of the origins of sensometrics and where some of that comes from. So I think we sort of, is it new wine on old bottles or whatever the saying goes, how does some of this thing? And then I was surprised by one thing, and this is, I guess, my question to you. You emphasize time savings, and I think I also see a separate component that you didn't mention, which is ecological validity. So this idea, right, that, for example, the product reviews, take your whiskey example, right, that people provide descriptions from whiskeys that they have drunk at home or in different settings, right, and that it addresses a major criticism of a lot of sensory and consumer work, which is that it is not done in ecologically valid settings, right? And the whole point of some of these reviews, for example, or Twitter data or other things, is that they're generated by consumers often in an actual context, or at least they're not generated in this artificial lab type setting or, you know, recall surveys. So I guess my question to you is, do you see that as the main driver or a secondary driver of the push towards some of these models? And I guess John can answer that too, because that's where I'm coming at it from.
I'm trying to break down all the components of the question. The first one was whether it's like new wine in an old bottle, and I think that to some extent, yes. Like, you know, I teach people segmentation in my consumer research course. It's unsupervised learning. I mean, it's the same. And I actually think that people who do sensory science actually have really advanced statistics skills that they could rebrand as some sort of advanced data science. It's just a different, I mean, so I do agree that to some extent it is the same thing, just in a different label. To some extent, it's a lot of hype. I try to pick examples that I thought were actually like useful, because there are also, with any hype, it's not just in food science. There's a lot of people right now using machine learning for the sake of saying they can use machine learning on their paper, when the results, you're like, okay, what problem are you solving? Are you even solving anything that's relevant? People just want to use it because it's shiny and new. And that's why I really try to stress that it's important to think about whether your problem is relevant for machine learning. Although I do think one of the benefits is that it can handle these non-linear relationships. And I think that's actually where the power is, but we're just starting to explore that aspect. In terms of ecological validity, I don't know if it's necessarily better ecological validity, because of course the kind of people who would use Twitter or use Instagram, that's also a kind of biased sample. It maybe into a way it's also weird, just in a different type of weird. I mean, I know of, or I guess I can say, at least in Givaudan, what they do is they do a lot of these kind of social media driven trends, and then they do kind of sensory testing based on the trends they get. So it's this like two-step approach, where you do the very broad strokes with, say, social media, and then you'd have a more human-centric focus. I'm not sure if the human-centric focus as intermediate step, whether that's just something that will eventually go away, or whether that's something they intend to keep. So that's how I can answer the question. Maybe John can add.
Yeah, I mean, I think that a lot of the points that you made there are, you know, excellent in terms of, you know, where is the value of machine learning specifically versus classical statistical methods? In many cases, you know, they come to a converging answer. I agree with you that there is potentially a lot of power, especially the social listening, and possibly where the value will be in that ultimately is the ability to look at large quantities of historical data and find trends in that data that maybe do have non-linearities that you can make use of. Because I think that for some of the types of data that we're collecting, I mean, it's you know, you'd probably come to a similar outcome with some of the classical methods. I think that the question of ecological validity kind of comes to another point, though, which is methodological, in terms of what is the type of data that we in fact need in order to make a decision, you know, about a product. For instance, you know, if you're looking to run a consumer study and you've recruited consumers and, you know, you're testing 5 products that you've now, you know, gone through some development on, and you're collecting consumer opinions, you know, I ask myself, what is the actionable result that you're looking to get for your 5 products for your company for the cost of running that study. And yes, ecological validity is a consideration, but so is effective decision making. And I think that the prospect of, let's say asking them to give their free comments, where you're now making a decision based on, 12 of 60 people who, spontaneously generated a particular word, I have to ask myself, could that study have been designed to reach a conclusion that's more actionable, more effective in terms of coming to an outcome? Because we know that there's this tip of the nose phenomenon where people have a hard time identifying an aroma that's completely unprompted. Many consumers, if they taste something, they'll tell you that it's that's good, and they'll give you maybe a texture attribute. They have a much harder time generating aroma attributes. And, it kind of reminds me of, you go back, let's say 50 years or 40 years to people who were saying, these are not tasks that consumers are really good at doing. And so, and this kind of comes back to your point about, what is, will we see a reemergence of the trained panel? Because what we see in journals, is being driven by the needs of academia and the needs to produce something novel, as opposed to within a company where there's a need to provide actionable results for a business decision. And those are different priorities that are driving those, and so there's no value in a journal to providing a manuscript saying, here's a manuscript, it's not novel at all, please publish it. Whereas in industry, they may have a method that's very effective that they want to continue using. And people have this idea that they have to go towards novelty.
But I can tell you as editor of Food Quality and Preference that we would love to see papers of a debate nature, I think, on this topic that goes, okay, so what, where is the value that this type of work does? What are the comparative studies that show that studies that have used method or machine learning or AI or whatever it is actually generate more value? Because again, the papers that you pulled up, Janice, are a study that shows I have used this method for this product, but it doesn't give me an idea of whether I would have been able to make a better decision or get the same insights as if I had used one of the traditional methods. And I think that's where, you need to sort of consider hype versus substance, right? And I think that's the debate that as a science community, it would be very nice to have, and discussion papers that do that type of stuff, I think I would like to invite and participate in.
Thanks for all your answers and questions. One thing I wanted to also add is, I think sometimes we're too much focused on solving the business questions and considering sensory science as a means of answering the questions and understanding the consumer responses and perceptions. But as we also included like chemical senses, and we're talking now into more like the brain activities and all that. And also Sarah pointed out the, in order to understanding the new food materials and other materials used for personal products and other uses for sustainability and all that, I think we may need more time-consuming research to understanding the pure chemistry and also interactions between chemistry and human biology. So I think just focusing on this efficiency in terms of getting the problem-solving issues is only part of this sensory science. I think we should think more towards the basic training, basic science training, to play an important role to find out this more fundamental sensory science question. Actually, this is, I think, a bigger area than food science or other science, really combining this social science and enology and social science, and we are creating particular convergence, multidisciplinary science area that can impact broader field and science itself. So I also think the comment of Sarah on ecological validity is so important, because not only the efficiency of getting data, but understanding the language and also this semantic space that we're using. The quality of itself is very, very important for building up these models, right, to interpret the output. So I think, like, from our discussion over a few days, we could structure the different, also the linkages of different specialties. Like Professor Seo mentioned, we should have a linkage of different specialties to really strengthen our field and have the outcome out of it.
Yeah, great comments. Thank you.
So if I can add to that, I really agree with you. And I think it goes to show that the field is so broad, that again, one person can't span it all. And so for me, what is necessary is that we define and we consider the field broadly enough that there is room for these people that work in one area of the field and interact with somebody else, and they may not cover another part of the field and their interactions. But as a community, we have to be broad enough to do all of that. And if I can use that as a segue, it's actually a question back to Paul, because I think your talk was about, I guess, implicit methods, if I to put or indirect methods to put, if I just sort of captured it, and that's another, I think, area where there is development and contention within the field, because it has traditionally been extremely reliant on direct and explicit methods, and there is this development through technology for doing something else. And I guess my question to you is, how do you see that evolving over the next decade or two?
That's a challenging question. Yeah, I must say that if I look at what I've seen in my career so far, that maybe initially we were rather positive about the implicit methods. Some of these methods, I think, for me, they have not proven extremely useful. For example, many of the arousal-linked measures are they're aspecific. We spent an entire project on trying to do better than the liking score, including EEG-type measures, fMRI measures. I don't think honestly, we were very successful at that. But on the other hand, there are these neuromarketing-type companies. I don't believe all of them, but I know some of them that I do think are run by decent scientists. So those, to me, they are more credible than And I do think that the advance in AI-based methods, one of the advantages, provided you have enough data of sufficient quality, it has the potential to be more sensitive. But I think the problem is often, it depends on what you want, the goal you want to reach. So in some domains, people want to be able to predict individual responses, which is really hard. I think the discussion I've had around the neuromarketing type or implicit measures is also how well can you predict, let's say, the response of a certain consumer segment based on a relatively small subsample. Because usually we have like maybe 20, 30 people. We do some advanced measurements, and then yeah, the claim is that it would predict the response of a larger group. And I think it has a lot to do with defining again. Yeah. So that I have doubts about the specificity, but yeah, we shall see. I'm pretty critical about it. Yeah. And I think it also relates to what John said, that I think you're completely right. So for a company, they just need a consistent method that produces consistent results. And if it works, it works. There may be no need at all for fancy stuff. If a trained sensory panel can do the job, why not use a trained sensory panel?
So your question, Sarah, actually invoked my memory of 20-some years ago. There was Pangborn in Minnesota, and Zeta Vickers and the team, Susan Pecor, they had these cartoons up. Yeah, and one of the cartoons was, there was like neuroimaging kind of thing, and then the panelist was just sitting there, and then the researcher's like, oh yeah, we're done. I was like, we're not getting crackers and water either? Like, there was no food. They're just automatically just extracting information from their brain. So from what Paul said, that's not something that's in the near future, which is great to hear, because I always believe that the direct human measurement is always higher superpower than any other instrumental measurements. And I do say that subjectivity, objectivity, yes. I argue, if you talk about data, accuracy and precision, so precision is more reproducibility, and people think that because it's precise and reproducible, that is more objective. And I say, well, the instrument does not buy goods. So if you really think about accuracy and what is actual meaningful data, then it's only the humans that can give you that. So if you are going to say that human data is subjective because it's not as precise as instrumental data, I would like to argue with you. So that's kind of what I'm saying, like in terms of subjectivity and objectivity. And for machine learning or artificial intelligence, as limited knowledge I have, if in order to have a valid model that actually can learn, you need to feed data that is valid. And as you feed more data, the model learns to become more precise, right? So in fact, you do need those direct, very valid data. So that's why I'm saying, like, I don't think we can ever veer away from human subject direct data measurement.
Yeah, definitely data quality and also the sufficient data are very important factors. And also, let me add something. Maybe the implicit measurement is quite effective and nice tool, but sometimes it's very difficult and challenging to compare and to make some consistent between explicit and implicit measurement. Because if we are lucky, actually they are consistent. But in many cases, sometimes they are not consistent. So at that time, it's very difficult how to make a conclusion and how to interpret the result. So I think I gave some question to Paul during the break. So we have several scholars in working in the neuroscience areas. So we have fMRI studies and EEG, but actually we don't know what is the gold number for data collections. How many subjects actually we need for fMRI and for EEG? Because for consumer data, for sensory science, for just traditional sensory consumer acceptance data, actually we have certain kind of agreement how many consumers we need. But for EEG or fMRI or neuroscience techniques, do we have any kind of agreement in terms of number of participants or subject?
Yeah, that's a good question. I think many studies, especially in the past, were vastly underpowered. So that gives a bias in the field, because then what gets published are I think the effect sizes of those studies are larger than the actual effect size. So one of my former PhD students got a grant to do a replication study, and there you see the exact what you might expect. So to replicate something, you need more people. And I think what you see in the field, that sample sizes have been increasing.
Mm-hmm.
So in the distant past, they would advise you to do 15 people.
15.
If now you have 15 people, you're being laughed at. I think. I mean, for certain paradigms, it's simply not enough. So there are two ways of doing it. One is like, just based on, let's say, common sense. But the limiting factor is the money. And I think that is also behind the modest sample size. It's simply the cost. And just to get the cost is not the imaging itself, it's the personnel time you need to do the imaging and the analysis. The personnel is the most expensive part, not the MRI machine. Many people think that.
And there as well.
But if you really want to do it properly, then you need data with your task from a small population or of a similar task, and then you can do an actual power analysis based on data to estimate how many persons you would need for this study. So now the tools are available to do this. 10 years ago, it was simply not available.
Can I add a comment? Oh, thank you. I just want to add a comment about the cost side of things and how that relating to sample size, because I think Paul is very fortunate. He has free access to a scanner, which many of us don't.
We pay.
Oh, okay, not as much as us. But so we pay quite a lot for the machine that Paul showed, like to scan the brain. I think cost is definitely a factor, but that actually influences research, right? Because it costs us so much. So lots of papers traditionally have like 20 people, 26 people. I think 26 is a magic number or something. But my point is, recently I wrote a grant and I talked to someone in the expert doing the brain scanning all the time. So I said, how many people should we put on? And then he said, as many as possible. Okay, like so I calculated all my budget. I was like, okay, we can do 90 people. And then he said, okay, that's too much. Okay, we don't want that much. So I think we still do lots of those estimates based on experience and based on their resources and stuff like that. And as Paul said, the proper way is we should do it as any other methodology. We should estimate power, we should do pilot testing, we should do all this prior testing. But unfortunately, I think in the field we're not yet doing that. Yeah.
And I just want to add one more thing. This is not we're not gaining up on you. You are very lucky to have access to your scanner, because when I did an fMRI study, there was also availability of when the machine was free, because we were competing with everyone else in the hospital. So we only got 2 weeks' time, and it's as many people as you can cram in as possible. So there's lots of real-world constraints.
You live in the first world, Paul.
Okay, so we have a time limit. Maybe one quick question if you have. No? Okay.
Can I say that? So I just thought to perhaps round this up, because I think some of these last conversations, I think, have touched on something we haven't necessarily spoken about explicitly, but which is also relevant when you're starting out on your career, if you're in academia. May mentioned it, it's about finding some good research questions and then bringing it back to Haesung's question around what should people learn. And I think philosophy of research, understanding what is a hypothesis, what is a good research question, what is the alternative hypothesis, and actually learning to structure, build up research that way, because it improves the quality of your research, and it certainly improves your chances of getting published if that's what you're trying to do.
Okay, I think we all demonstrated that how all our distinguished researchers are passionate about sensory and consumer science. Thank you everyone for staying through the 3 hour of talk and question and answer and discussion. I would like to thank COAST again for allowing us to invite everyone and have this BrainLink X Lab Day talk concert and also conference following today. Thank you everyone.